So this video is related to project of finite difference time domain simulation of electromagnetic waves in MATLAB. So in this paper, basically we have just defined the two-dimensional finite difference time domain simulation of electromagnetic wave propagation in transverse magnetic Z polarized. We shortly called it TMZ mode, and in that simulation domain consists of 2D grid with NX with NY cells accordingly 200. Okay, so I have just written FDTD basically is the finite time difference time domain is basically we will call that in short term FDTD. That introduced by Yi was a scientist in 1966, and he just updated the electromagnetic field with each time step using the finite differences. So the time steps was running of this complete function for 500 time steps in the field, or taken the various time steps with the FDTD. So I have written the complete abstract with the keywords of and introduction. Introduction is basically here is just defined how the finite difference time domain functions works in terms of x and y axis. Okay, so with the z axis accordingly, like it works how the magnetic field moves from one side to another side in 3D domain. Okay, so here is yes the complete simple graded observing layer with the PML implemented through reflection at the boundaries. Gaussian sources basically placed at the center of the grid to excite the electromagnetic wave as well. So here is the FDTD method with the explanation, like how the FDTD method works in the propagation of electromagnetic waves in various medium according to the different antenna design. Basically this technology is used to design in terms of antenna design in microwave engineering and the political or optical communications basically. So here is a simulation setup. Simulation setup we normally use a 200 for the axis in terms of x and y axis cells. Okay, because we are using 2D grid mesh grid for the time domain. And yes, FDTD algorithm and FDTD is method and FDTD algorithm is separately defined in MATLAB. How we are using the Maxwell equations in the space and time for the updation of the each time step using the finite difference equations. So in the MATLAB basically some electromagnetic wave propagation tools are available which we used in our observations of simulation. Absorbing boundary conditions are implemented in these tables for the parameters of the FDTD, and the Maxwell equations as well included in it. So here is the FDTD region of absorbing boundary conditions, as well as these are the source parameters for the Maxwell's equation, and the numerical stability is defined in terms of coherent Friedrichs Levis. Basically, this is the CFL condition. Basically, he was the scientist who explained that the main numerical solution for the stability and the accuracy in terms of electromagnetic theory. Okay, so here's the problem statement with how we are using and the simulation domain in terms of 200 by 200 grid with the Gaussian source at the center, and our main objective is the propagation and observation absorption by the perfectly matched layer with the time steps of 500 steps. Each steps taken from 100 with the difference of 100 time steps. Here is the mathematical approach. These are the equation we are using for our case. Okay, yes, these are the complete equations, numerical stability equations, and the methodology is defined here. In I have just added the complete algorithm from Yi scientist to CFL scientist, and then the design MATLAB simulation with the simulation parameters as well as the its output results according to different time steps. So here is the expanding front with 200 time step, and here the expanding time step with 300 time step with mid propagation. Output results for the PML at 400 time steps, 500 time step with the PML absorption. Then results and discussion according to the time steps with its description, like how 100 early wave propagation with expanding wavefront with mid-domain propagation, wave approaching boundary, and PML absorption at 500. Then I have written the conclusion with the references. Let me just show you. Yes. Okay. So here is a folder where you just need to open this file first. FDTD 2D wave propagation, and after that you just need just a second. I think MATLAB is not responding. Let me check it. What is the issue? Okay. Let me open the MATLAB. Okay, let me run the FDTD 2D wave propagation MATLAB simulation output results for this section. This is the complete code for the, see, these are the output results for the different time steps of, like this is a figure 1 for the early wave propagation with front expanding front. Next one is basically third is the mid propagation, fourth one is PML, near PML, and the PML absorption. These are the 5 figures are as the output results. Okay, so you just check it, and if you need to ask anything, you just call me. I will answer your questions. Thank you.